notes over quadratic applications. So look at number 1. You are standing on the baseline of a tennis court and you want to practice your soccer skills. You want to kick the soccer ball from one baseline to the other 78 feet away, but at the same time only clear the 3-foot net by 1 foot. The ball will travel in a parabolic path with its highest point being 1 foot above the net. So imagine you're looking at a side view of a tennis court, right? So here's where your ball is, because on part A we're drawing a picture and labeling key points, because you'll know I think a picture is worth a million words. Okay, so here's your ball where it's starting at. So this is horizontal distance 0, height 0. That's this point. Okay, here's the halfway point from one baseline to the other. That's where the net is. So you can imagine the net being here. Now remember, from one baseline to the next, it's 78 feet away. From one baseline to the other, it's 78 feet away. So 78 is the horizontal distance. And again, hopefully when the ball lands here, it has a height of 0. Okay, the baseline here is at height 0. This middle point here, the vertex, if you will, as you know, okay, is going to be halfway in between the horizontal distance from 0 to 78. So that halfway distance will be 39. And we know the height, the highest point is going to reach 1 foot above the net, and the net is 3 feet. So this will be a height of 4 feet. Okay, so now we've got our picture with key points. Now we're going to describe a reasonable domain and range using set notation. Now the domain and range is really just to help you with the window for the calculator when you plug this in. So you're going to want to go outside of this picture so it will show up on the calc. So don't just use these values, go a little bit outside of the box. That way on the calculator you can actually see the entire picture. So will your answer always be the exact same as mine for this? No, because you might go a little more than me or a little less than me, and that's okay. So for the domain, we are going to start at 0, our horizontal distance at 0, but instead of going to just 78, because we don't want this to be the end of the window on the calculator, we're going to go a little bit further. So we're just going to go to 80. All right, and similarly here, we're still going to start at 0 for the lowest height, but how high does it go? Well, it really goes to 4, but again, kind of like I did, I went 2 more than the horizontal distance. I'm going to go 2 more than the vertical distance. So I'm going to go to 6 because I want to see a little bit more than that on the calculator. And we're going to get to that in just a minute. So part C, write an equation in vertex form. That's why I've written vertex form here, relating the height of the ball to the distance traveled. So that's what we're doing here. The height of the ball related to the distance traveled. Okay, horizontal distance traveled. So how do we do that in vertex form? Well, you're given a point, actually 2, but we're going to use the easiest one. We're going to use the 0, 0 point. And you're given the vertex, which is 39, 4, and we're going to plug that into our equation. So remember, this is your x and your y, and this is your h and your k. So plugging into vertex form, we would have y, which is 0. So 0 equals, we don't know a. X is 0 minus h, which is 39 squared, plus k is 4. All right, so here we have 0 equals 0 minus 39 is negative 39, and negative 39 squared is 1,521, so we would have 1,521a, all right, plus 4. So of course, this plus 4 is going to jump over the equal sign and become negative 4 equals 1521a. Divide both sides by 1521. You get negative 4 over 1521 equals a. All right, so we've got our a, but of course we need our equation. So y equals negative 4 over 1521 x minus 39 squared plus 4. Okay, so this is our answer, But you'll notice there's a D and a C, and there's going to be, for all the other problems, there's going to be other parts. So once you write the equation, you want to check that equation, because if this is wrong, all your other answers are going to be wrong. So we are going to use trace in calc to check this equation. All right, we want to check the equation. Well, how do we do that? Put equation in y equals, all right, which I have already done, so make sure you're paying close attention. I've put the equation into the y equals, and then you're going to use domain and range for the window. So I am going to, that says window, I'm going to go to my window, and my x min is 0, perfect. My x max is going to be 80, and I'm going to scale by 5. Okay, that means what am I counting by? To get from 0 to 80, am I counting by 1, 2, 3, 4, all the way to 80? No, I'm going to count by 5. So 5, 10, 15, 20, all the way to 80. And then my y min is 0. That's already good. My y max should be 6. And to count from 0 to 6, I don't need to count by 5s. That would be ridiculous. Okay, I'm going to count by 1. So 0, 1, 2, 3, 4, 5, 6. Okay, then I'm going to graph. Make sure my picture looks pretty similar to my picture here. And then I'm going to hit trace. I'm going to hit trace and check 2 points. Okay, so I'm going to hit the trace button, and the 2 points I'll always want you to check are the last 2. So you hit trace, and then you hit 39, because that's the x value, and it should come up with the y value. And it does, 39, 4, so we're good. So then I'm going to hit, I don't need to hit trace again, I'll just hit 78, enter, and look at that, 0 comes up as the y value. So if my points are matching up with the trace key, then my equation must be right. So my equation's right, so then I can answer my next 2 questions. Is the vertex a max or a min? Well, that's easy. It's a max because that a value is negative. List the transformations in regard to the parent function. Okay. Reflect over x-axis. That's the negative. The 4 over 1521, not because of the negative, but because of that number, is less than 1. Then we will say a vertical shrink by 4 over 1521, comma, a movement right 39 and up 4. It's just a V, vertical shrink. Okay, number 2. An arrow is shot over a lake. Okay, so here's your arrow is shot over a lake from a cliff that is 20 feet above the lake. All right, so that already tells me my first point here, because I know I'm going to have to label the picture. So the horizontal distance here is 0. That's my starting point. And the height of this cliff is 20 feet above the lake. This must be the lake. Here's my arrow. Here's the cliff. So the arrow returns to the same height as the cliff at a distance of 160 feet from the cliff. So when I'm 160 feet away from the cliff, this is 160 feet away from the cliff, my arrow reaches the same height. So that would be 20. Its path traces a parabola and reaches a height of 60 feet above the lake. So that's my highest height is 60 feet above the lake. So 60 is the height, and we've got to find that horizontal distance. So how do we find the horizontal distance? Well, this is a parabola, y'all. This is the vertex, and we know that these 2 points, because their heights are the same, the vertex will be in the middle, right? So from 0 to 160, the middle would be 80. So that's my middle point there. Okay, so now I've got my 3 points. I've labeled. Now let's do that reasonable domain and range and set notation. Oh, interval notation. Oh, before we did set, now we're doing interval. So domain is going to be from 0 inclusive This is 160, but again, if we want to see the whole picture, we want to go kind of off the screen. So I'd say that's about maybe 180, I'm going to guess, but we might have to change it. That's okay. Our range definitely goes from 0, that's when we're on the lake, to 60 is the highest, but again, let's go a little bit off that, so like 65 or 70, just to make sure in the calculator on the screen we can see the whole graph and it doesn't cut it off. Okay, so from 0 to 70. So write an equation that relates the height of the arrow above the lake to its horizontal distance. So same as before. We've got vertex form, we've got a point. We'll use 0, 20. You could use this point. I personally prefer smaller numbers. So 0, 20 will be our X and our Y. And then our vertex is the ordered pair 80, 60. So of course that's your H and your K. All right, so we've got Y equals, so 20 equals X, which is 0 minus H squared plus K. So we've got 20 equals negative 80 squared, which is going to be 6,400. So 6,400A. Oops, I forgot my A right here. Right here, this needed to say 20 equals A. All right, so 6,400A plus 60. Subtract 60 from both sides, right? This positive 60 needs to move over here. So that becomes negative 40 over 6,400A. So of course you divide both sides by 6,400. And when you simplify, all right, your zeros here cross through, and then 4 over 640, you're going to get A equals negative 1 over 160. All right, so of course that's just our A. We need our equation. So X minus 80 squared plus 60. So this is our equation. We better check it. I don't even want to move on and answer my other questions without checking, because I'd hate for my other answers to be wrong. So I'm going to go to Y equals. I'm going to pop in that equation. 1 over 160. X minus 80 squared plus 60. I'm going to go to my window. I'm going to use 0 to 180. I'm going to scale by 10 because I don't want to count by 5s. That would take forever. I'm going to count 10, 20, 30 all the way to 180. And then my Y min is 0. My Y max is 70. I'll probably count that by 5s. And then I'm going to graph. I'm going to let that process for a minute while I remind you that you're going to use the trace key in the calculator. So trace. We put the equation in Y equals, we use the domain and range for the window. Now we hit the trace button and we're going to check 2 points. So we're going to check these 2 points here, 80, 60, 160, 20. So 80, once you hit trace, you hit 80, enter, and look, 80, 60. We're good. So then we're going to check 160, make sure that 120 is what comes out. So hit 160, enter, and look, 20 is what came out. So we checked our 2 points. That's really, really good. That means that we can move on with our questions. So part D. What is the arrow's height above the water? So we don't know the arrow's height. Height, remember, deals with Y. So that means it's asking about Y. So what is Y? Question mark. What is the height above the water when it has traveled a horizontal distance of 100 feet? So it's giving you the X. It's giving you the horizontal, which is X, and it's wanting to know the Y. So how would you figure this out? Well, you've got the equation. You have a couple of choices. You could certainly plug in X, plug in 100 here. You could type that in the home screen and get out your Y. But we've already got the calculator here. We've already got the trace key on. I can go ahead and hit 100, X equals 100 here, hit enter, and it will give me the Y value. So the Y, the height at at the distance, the horizontal distance of 100, the height is 115 divided by 2. Well, 115 divided by 2 is 57.5. Okay, so what is the answer here? The height would be 57.5 feet. Does that make logical sense? Well, at 80, we're at 60 feet height. So shouldn't it be on the downward descent at 100? So from 80 to 160, we're going down, so my height should be less than 60. That makes perfect sense. So that answer seems logical. Okay, so now let's do part E. At what distance from the cliff? So if we're talking distance from the cliff, we're talking horizontal distance. So we don't know the X. Will the arrow strike the lake? Well, when does the arrow strike the lake? What do we know about that point there? We know when the arrow strikes the lake that we don't know the horizontal distance. We don't know that. But we do know the height is 0 there. So when the arrow strikes the lake, the height is 0. Okay, so what we can use is we can use the calculator to find out what that point is there. We can do second trace 0, that's an x-intercept, second trace 0, and of course use your skills that you've learned from way back when. Get that left bound. See how here it's asking for the left bound, so hit enter. And then you're going to have to go off the screen to get the right bound, hit enter. And if you hit enter again, it should work. So it's saying that that horizontal distance is 177.9795. So that's going to round up to 80. So the answer is 177.980 feet. And again, did that make sense? Yeah, that distance makes sense for that point, 177.980. And how did we get it in the calculator? We did second calc, and we did number 2 to find the 0. So write that down if you need to know the buttons. So that's how we found it in the calculator, because that was an x-intercept that we were finding. It was a 0. All right, so part F. As it travels, how many times will the arrow reach a height of 40 feet? Well, the arrow will reach a height of 40 feet on its way up, and it'll reach a height of 40 feet on its way down, right? So how many times will it reach a height of 40 feet? Twice. And then calculate the horizontal distances where this occurs. So again, calculate horizontal distance. We don't know x, but we do know y. It's giving us the height is 40. Now the trace feature of the calculator works when you give the x, it gives the y, but we don't know the x. So the easiest way to do this is look at on the graph. All right, we want to know when the height is 40, so go to the y. We want a height of 40. Look at that. So there's where my height is 40, and there's where my arrow reaches a height of 40. So in the calculator, you will plug in 40 to y2. So that's your first part. Plug in 40 to y2. And then you'll do second calc. All right, second calc. And you want to find that intersection of those two lines. So second calc, and number 5 was intersect. Intersect. And you'll have to do that twice. You'll have to do this part twice, right? Because there's 2 intersection points. So you'll have to do this twice. So let's get the one on the right first, since my cursor was closest. Oops, second trace. There we go. 1, 2, 3. I hit enter three times, excuse me. And there's my horizontal distance and my height is 40. So my horizontal distance is at 136.569 feet is one of them. And then second trace 5. Now I'm going to have to go all the way to the other side. All the way to the other side and hit enter, enter, enter again. And the other one is 23.431 feet. So those are my two places where that occurs. Okay, so last problem, number 3. All right, the main cables of a suspension bridge are 40 feet above the road at the towers and 10 feet above the road at the center. The bridge is 200 feet long. Vertical cables are placed every 20 feet. The main cables hang in the shape of a parabola. So this is kind of already giving you the picture, the idea with the cables here. So the main cables of a suspension bridge are 50 feet above the road. Okay, so this one here is at 0, 50. This is the main cable. Okay, and also it's going to be at 50 here. The main cables, the first and the last. And we are 10 feet above the road at the center. So notice this is our center cable and this is 10 feet above the road. Okay, the bridge is 200 feet long, so this horizontal distance is 200. All right, the vertical cables are placed every 20 feet. So I did plan this out because this goes 20, 40, 60, 80, 100 has to be in the middle between 0 and 200. 120, 140, 160, 180, 200. So I have planned out these lines strategically. Okay, describe a reasonable domain and range using set notation. So set notation again. Domain is going to be from 0 to, let's go to 220, 225, something like that, past this. And then our range is going to go from 0 to, let's go to maybe 60, 75, somewhere around there. Again, yours might not be exactly the same as mine. Now let's write an equation. Let's pick a point, 0, 50. So x, y, let's pick the vertex, 110, so h, k, so 50 equals a x minus h squared plus k. So 50 equals, this is 100 squared, so this is going to be 10,000 a plus 10. Of course, this is going to move over. So this will be 40 equals 10,000 a. So divide by 10,000. Divide by 10,000. And as a fraction, you're going to get 1 over 250 equals a. So y equals 1 over 250. X minus 100 squared plus 10. So that's your equation, but remember to check it. Check, 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 check. So use the trace key and check. We don't have a lot of time here, so I'm not going to. Is vertex a max or a min? It's a min. How high is the third cable? Okay, so this is the main cable, so we're talking 1, 2, 3. How high is the third cable? So assuming we checked this, assuming this is right, it is, but please check yours every time. How high is the third cable? So the third cable, the x, the horizontal distance is, remember these are placed every 20 feet, so 2, 4, 6. X equals 60 feet. So if you plug this in for the trace key and hit 60, the height that you get should be 16.4 feet. How high? Remember, you were wanting to know what is y.